Okay, so now we're going to take a look at what's the derivative of the exponential functions. Functions like, for example, 4 to the x, 7 to the x, e to the x, the natural exponential. What's the derivative of functions like that? So let me draw a picture here before we go through this. So this guy, if I draw the general exponential function, it looks something like this. Now, since we don't know what it is, why don't we find the derivative using the definition. So the derivative of a to the x is now, you remember the definition of the derivative, right? Okay, so that's the limit as h goes to 0 of, why don't I write it down up here? So the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so then what I'm going to have is the limit as h approaches 0 of a to the x plus h minus a to the x over h. Okay, so if you look at this, if I plug in 0, I get 0 over 0, which is an indeterminate form. Now, what I want to do then is try to figure out some algebra to do here. So notice that a to the x plus h, let me write that right here, a to the x plus h, that's the same as a to the x times a to the h by the laws of exponents. So then what you can do is you can rewrite this guy as the limit as h approaches 0 of, you can take out a to the x because it's common to both of those guys, and then you would have a to the h minus 1 all over h. Now notice also though that a to the x doesn't depend on h at all, and so you can take that a to the x outside of the limit. Now if this guy had an h in it, then you wouldn't be able to, but because you're going you're taking the limit as h goes to 0, this guy can be taken out. So then you would have a to the x times the limit as h approaches 0 of a to the h minus 1 all over h. Okay, now this guy, our problem is we need to find this guy right here. And one thing to notice though is that this guy right here, so if f of x, my function, is a to the x, notice that this guy right here is equal to the derivative at 0. So this guy is a constant. This guy is just the derivative at 0. So notice if you use the definition for x equals to 0 of this function, you would get exactly that. Okay, now we aren't able to explain this yet, but this is actually equal to natural log of whatever that constant a is. Okay, so for now, you just have to trust me. But later on, I'll show you where this one comes about, because we don't know enough to prove it. Now, one thing to note, so let me write this down. Let's go down here. So then what that gives us is that the derivative of an exponential function, a raised to the x, where a is a constant, is equal to a to the x times natural log of a. Okay, so that's the first one. But then also notice that the derivative of e to the x, so remember e, the special number, 2.71, blah, 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 is equal to itself, just like this guy. But then what's natural log of e? Well, that's just equal to 1. And so, you know, whoops, sorry. So this function, the natural exponential, its derivative is equal to itself. And I mean, that is astonishing. That's crazy. What we're saying is that, and actually this is the only function that has that property, is that, so if this guy is e to the x, for example, if you find the y value at any point right here, for example, this at x equals 2, this guy would be e squared. The derivative at this point, the slope of the tangent line, is equal to the same exact number. At any point whatsoever, the slope of the tangent line is equal to the y value at that point. That's just nuts. But that is what it is. Okay, so let's do a couple of examples. Let's say we want to find the derivative of 4 times 3 to the x minus 5e to the x. Okay, so notice that I've got a constant here. And so since I have a constant multiplying my function, I'm just going to leave that guy alone. And then the derivative of 3 to the x is itself 3 to the x times natural log of the base, which is 3. So that's what that rule tells me right here. And then minus, and here I have 5e to the x, so the constant, again, just stays the same, 5, and then the derivative of e to the x is just itself. So that's it.